Okay, I'm here to talk about the comparison test for series, and also to explain how to use the Cauchy criterion, which seemed to be the punchline for every single proof in this chapter. So just let me quickly rephrase the comparison test. It says if you have positive terms of each of these sequences, and the b's are big and the a's are smaller, if the sum of the b's converges, then the sum of the a's converges, and its contrapositive is also true, of course. If the sum of the a's converges, then the sum of the b's diverges. To kind of rephrase this, what this basically means is if something bigger converges, right? If it converges, that means it goes to a finite number. Because you're adding up just positive terms, because everything's bigger than 0. If something bigger converges, then the smaller thing converges. Also converges. Let's see, converges. And similarly, if something something smaller diverges, which basically means goes to infinity, then something bigger is also going to go to infinity. So that should be diverges. And you know what? This here should be diverges as well. So I like to think about these things in terms of big and small. Converging means that it's small. Diverging means that it's big. So if something big is small, then something smaller is also small. If something small is big, then something bigger is also going to be big. So let's get to the proof. The proof, I'm just going to prove 1, since 2 is just the contrapositive. Since BK converges, and let's, as we should usually start, let epsilon be bigger than 0. I'm going to use this epsilon to prove that the a sub k converges. So that's the guidepost. That's what I need to do to prove that the a sub k converges. Is I need to show that basically the sequence of the partial sums has to be less than epsilon at some point. So since this converges, by the Cauchy criterion, which I'll denote CC, there exists an n such that for n bigger than m, bigger than or equal to n, I know that b sub n plus 1 plus da 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 plus b sub n is less than epsilon. The same epsilon that I need to use for the a sub k's. Right? That's just what the Cauchy criterion says. Now the question is, can we find, and how about n naught, such that for all n bigger than m, bigger than or equal to n naught, a sub n plus 1 plus da 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 plus a sub n is less than epsilon, where this epsilon is the one that I set out to begin with? And the answer is yes, with exclamation points. I'm going to let n naught be equal to this n right here. If you let n naught be this n, then for m bigger, n bigger than m, bigger than or equal to n naught equal n, we have, well, I need to show that this thing is small. But the Cauchy criterion says that this thing needs to be small. Oh, but each of these things is positive, and each is less than the b sub k's. So this is going to be less than or equal to the sum involving the b sub k's. Oh, but wait. This capital N here, which is the same as n naught, guarantees that that's less than epsilon. So by the Cauchy criterion, by CC, this thing converges.